Welcome back, guys. This video is going to be on Leetcode 19, remove nth node from end of the list. We are given a linked list and we are asked to remove a specific node starting from the end and traversing n steps. So n right now is 2, so I start at the end of the linked list and traverse 2, so 1, 2, and I delete this node. So it's a little tricky because we all know linked lists start at the head and then traverse. So this is kind of like a little trick they threw in there to make it a little bit harder. So to solve this problem, the first thing I'm going to do is just get the length of the linked list. So I'll come in here and make a variable called cur. I'll set it to the head of my linked list, which is initially node 1. And then I'm going to say while cur is truthy and exists, I want to traverse my nodes. So I'm going to say cur equals cur.next. So it's just going to traverse this linked list here. Then inside the while loop, I'm going to increment some variable called length. And I can create that up here. I'll set it to 0 at first. Now let's console.log length to find out if this is firing correctly. So that looks good. Okay, so now we need to find out how many steps we need to hop to get to this node. I could reverse the linked list and then just hop n steps, 1, 2, but that seems like a lot of work, and there's actually an easier way you can do this, and it's kind of a little trick. We can just take the length minus n, and that is the same thing, or the inverse of n steps. Just take the length and minus n. So now, if length was 5 and n is 2, then we know we need to do 3 steps to hit that 4. So if I'm right here, I go 1, 2, 3, and I've hit the 4, the node I want to remove. So again, let's make a cur variable and set it to head. All right, and I'll say while cur, same logic as above, cur equals cur.next, and then I want to decrement my skips each traversal. Okay, and then I want to check if cur.val does not equal 0. Or rather, if skips does not equal 0, sorry, because we're checking for the skips to equal 0, then I want to console.log cur.val. And I'm also going to console.log the skips variable just to see where we're at. So if I run this code, you can see when it hits 0, we don't actually console.log anything because 0 is that 4 value. So that's the node we want to delete. So this is actually looking pretty good. Now I need to create a result or somewhere to store all these nodes that I'm pushing, or like console.logging. The way I can do that, I can create a variable called dummy, which is just going to be a dummy node and basically a new linked list that I can store these values in. So I'll say let dummy equal new list node. I'll use a placeholder value of 99. You can use whatever value you want. Make the next pointer equal null initially. And basically, I'm going to come in here and say dummy.next equals some node, and then dummy equals dummy.next. Mirroring this logic right here, so we can just traverse our dummy list. So let's make the new node. So say node equals new list node. And it's going to be the current value with the next pointer of null. So this is going to not actually work the way we intend to, but let's console.log and see what happens. So you can see our logic is good, but it's returning a 5, and the 5 is at the end of the linked list. So what's happening? We're adding our dummy next appropriately, and then we're traversing the dummy next appropriately. So why is it returning 5? Well, we're losing the pointer to the start of the dummy linked list. So we need to actually make a variable to actually traverse the linked list, and then we can just keep a hold of dummy as the start. So what I'm going to do is I'll say let new head and initially set it to dummy. And if I replace new head here, let's console.log new head and dummy now, and just to show you what I mean. So here's our dummy list now because we actually still retain the start the starting pointer of the dummy list, and then here's the new head, which was the value that's being used to traverse the dummy list. So now I just need to get rid of this 99 and return dummy. So that's an easy fix. I can just go dummy equals dummy.next, and then I can just return dummy. And there's our answer. Okay, so a couple things to note. The time complexity for this problem is O of n because our inputs are directly proportional to the operations we perform. We're traversing that linked list the same amount of times as the amount of nodes in a problem, right? Like, we're not really dividing the nodes in half or by log n. We're literally just going over the proportional nodes, directly proportional to inputs. Likewise, the space complexity is also O of n because we have to create a new node that is directly proportional to n inputs. We pretty much are making a new node for each node that we traverse over. I hope you guys enjoyed this video. Make sure to like and subscribe, and I will see you in the next one.